All right, now we're really getting to the thick of things, okay? So this section, I guess I should go to the right screen. This section is function transformations. Okay, we're going to start off by talking about horizontal and vertical shifts. There are 10 different transformations from a certain point of view and 5 from a different point of view. 5 or 10, however you want to count it, transformations. And they're going to be very involved, okay? So you may have to watch the video twice. You may have to ask questions. You may have to do extra homework problems. Make sure to check your answers in here because this is where things really start to get kind of messy. All right, let's go back to this. Let's talk about some of our toolkit functions. All right, and we're going to talk about shifts, moving the graph up, down, left, right. All right, if I have a toolkit function, let's say toolkit function 1 over x. All right, this has asymptotes on the y-axis and the x-axis, and it looks like you see it. Okay, look at what happens if I add a 1 at the end. What happened right there? Let's see it from a different point of view. I have the same function, but I add 1. What happens from the blue to the orange? Well, the orange just got shifted up. Everywhere that there's a point on the blue is the same point on the orange, 1 higher. Every point that's on the blue, same point on the orange, 1 higher. Has the same vertical asymptote. Now notice that the horizontal asymptote also got shifted up 1. Everything got shifted up 1 unit, right? And similarly, I could, subtract 1. And now the orange graph is just the blue graph moved down by 1. You can see this a little easier with some other toolkit functions. Like, let's look at the square root of x, right? If I have the square root of x, notice how the orange is just 1 unit higher. Or we could add 2. Whoa, not like that. Or we could add 2. And the orange graph is now the same exact graph, just shifted up 2 units. So that's sort of the underlyingness of vertical shifts. Okay? Let's talk about that real quick. Your main thing in this whole section is one gigantic table. Okay? So we're going to start our table. It's going to be the transformation. Like a name, that's going to be the first column of the table. And then we're also going to have, I don't know, like I really don't like using the word formula here, but it's close enough. And then we'll have an example. All right, so just one giant table with 10 entries. So first off, vertical shift. All right, and this is going to be up C units. All right, so we kind of showed how that worked. All right, it's if we have some function and we add C to the outside of the function. So it's the same exact function, and then just at the very, very end, there's plus a number. So just like in our example here, where we had y equals the square root of x plus 2. We added 2 on the very end, and it moved it up 2. Likewise, we could have a vertical shift down C units. That's very, very similar. We just subtract C. All right, those are our first 2 transformations. Again, any function I want. Let's look at another function. Let's look at x cubed. Okay, if I take x cubed, I can type right. If I take x cubed and I move it down 3 units, notice that the orange graph is the same thing as the blue graph, just drag down 3 units. Okay? So this sort of begs the question is, what if I don't subtract a 3 on the outside of the function? What if I look at the inside of the function and subtract a 3 here? What happens? 2 things to note here with what just happened. It's a horizontal shift, which should not be too surprising since this video is called Horizontal and Vertical Shifts. More importantly, we subtracted 3 and it moved in the positive direction. I guess for you, that's that way. Okay? That's going to be a theme of this section. Anything you do on the inside of the function is going to work sort of backwards to what you might expect. Okay? Maybe you write it at the bottom of the table here in your notes, but inside of the function a lot of times means horizontal. All right. It also works sort of backwards. Right? A lot of people see subtraction and they would think, oh, subtraction means down or it means left. But here it sort of works the opposite of what you might expect, and that really will come back to play a lot. So again, we could look at look at the reciprocal squared function. All right. What does the inside mean here, right? Outside, sure. Add 1, move it up 1. That makes sense. Outside of the function makes sense here. But what does inside mean? Inside of the function just means wherever the x is, that's where you're subtracting the 1. So we're going to need to put parentheses down here and then subtract the 1 right inside. And that should move it to the right 1 unit. All right, let's move it more than that. X minus 5. The whole thing is getting shifted to the right 5 units, all right? The orange graph is the same thing as the blue graph, just kind of moved over. Or again, say we wanted to move it to the left, just change that to a plus. All right, now the orange graph is the same thing as the blue graph, just shifted left 5 units, okay? So that's exactly what we're going to be doing for horizontal shifts. So we have horizontal shifts. I'm going to say if we want to go right A units or left A units, well, to the right, again, it's sort of backwards from what you might expect. For the right, that's going to be on the inside. We're subtracting A. Left is going to be also on the inside, but we're adding A. Okay, so an example here could be like, I don't know, y equals the square root of x minus 2. This moves the square root function 2 units to the right. Or I don't know, y is equal to 1 divided by x plus 3 squared. This takes the reciprocal squared function and moves it left 3 units. Realize I was using a lot of square roots here in our example. They don't all have to be square roots. Okay, and those are the transformations that we're talking about in this video. Okay, we got some good examples coming up for you, but again, there's going to be a long section. All right, in my face-to-face classes, is usually like double the length of a usual section. All right, so hang in there, trying to break things up as much as possible. Leave the other rows blank. I hope I give myself enough room in here. Leave the other rows blank and we'll come back to them later in the future videos. Okay, so let's do some examples. The examples that I have planned for all of you, let's say example 1 to start, are really all coming from the textbook. All right, the idea is that these examples are as similar to your homework as possible, and some of these have really good graphs that we're going to be using. So the first one is from the textbook, and here's what it is. It's number 6. All right, it says, given this function, wait a minute, this is the wrong section. Section that you are currently working on right now. I was like, this looks really familiar. All right, let's do 3.5, shall we? So again, there's a ton of material at the top of 3.5 to give you extra things to look at. Remember, they do have the solutions shown, okay? You can look at the book and use that as a supplemental resource for your homework assignment. All right, so example 6. So if we have some function, and we have a square root function, if we shift that up 1 unit and to the left 2 units, how do we do that? Okay, so we need the square root of x, and we need that to go up 1 unit and left 2 units. We just consult our table. Okay, if we want to move it up c units, we add c to the very end. So here, we need to move this up 1 unit, so we add 1 to the very end. That's going to be our first step. Next, we have to move it left 2. So we're going to do another step to move this thing to the left. So we look at our table and say, how do we move things to the left? Well, we add how far we need to go to the inside of the function. So it needs to go left 2 we're going to add 2 to the inside of the function. In this case, that means inside of the square root. And again, inside the function always means where the x is. Okay? We'll be doing that a lot in today. All right? That's how you do that sort of problem. Move on to the second example. The reciprocal function, 1 over x, shifted down 3 units and right 1 unit. You do the same exact thing. Do this in steps. First, I guess that was technically step 2. First, let's focus on moving it down 3. Down. How do we do that? How do we do that? Down 3 is going to be minus 3 on the outside. Okay, so that's our first step. We say, all right, this is 1 over x minus 3 at the very end. Now we need to move it to the right. So we again consult our table. Say to move it to the right a units, we subtract a from the inside. So we need to subtract a, subtract 1. All right, so wherever that x is, we're going to have an x minus 1 now. So next is going to be 1 over x minus 1 minus 3. Down 3, right 1, and this is our answer. Okay. So again, I'm not writing out the full problems, but this is number 6, right? And number 8 from the homework assignment. All right, very similar to the first couple of problems that you're going to have. Now let's jump a little bit, okay? Let's jump a little bit to the next group of problems. If you have something like number 18, describe how the graph is a transformation of the original function f. This also wants you to utilize your table. So for something like number 18, how do we describe that? Well, first off, let's just do it in steps. What does a plus 3 on the outside mean? You can consult your table. And so, if this is example 3, and it says describe the transformations. Right, we have y equals f of x minus 2 plus 3. Let's look at things one at a time. What does this do? Plus a number at the outside moves it up. That's going to say up 3. What does this do? And again, watch out when things are on the inside. They're going to work backwards from what you might expect. Okay? So minus 2 on the inside is actually going to move it right 2 units. These are the two things that are happening here. And if you just want to write an answer like that, that's okay. You don't need very flowery answers. I just want to make sure that you know what's going on. Okay? That's the most important thing here. All right. So that's that. Next up, I want to do number 24 on the homework assignment. These are the really good ones. The graphical ones are the most important things to me in this chapter section. And if it's the most important thing to me, that means it has a higher chance of showing up on quizzes and exams. Okay, so just a little thing right here. So we have a graph of an exponential function. We haven't talked about exponential functions yet, but it's okay. We have a graph, and we're supposed to use this graph to graph the transformation. We're going to look at 24. Graph this same function, but with a plus 1 at the end. Okay, so what we're going to do, again, this was number 18. Now we're looking at number 24. This will be example 4. For us, we have this function. This is what we are given. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Just looking at the graph, it goes through this point, goes through this point, it goes through this point, and this point, okay? There's sort of 2 steps. Again, this is just given. All right? Sort of 2 steps. First off, look at what we have. We want to graph g of x is equal to 2 to the x plus 1. The most important thing, right, this is y equals 2 to the x up here, is identifying what transformation is. What transformation is this? We're doing something to the outside of the function. That means vertical. Plus 1, that means it's going to be going up 1 unit. So when we graph this, if I want to graph g of x, what we do is we just take every single one of these points and move it up 1. This point moved up 1, goes right here. This point moved up 1. And by the way, getting colored pencils or colored markers is very, very beneficial. This point moves up 1. This point moves up 1. And there's a horizontal asymptote at 0, which means that when you move that up, we're going to have a horizontal asymptote at 1. So our g of x just becomes like so. G of x is the red graph. And it's the same thing as the given function. Again, you didn't remember what the problem looks like. This is given to you. We just moved everything up 1. All right. That's the sort of answer that I'll want from something like this. All right. So next up, 2 more examples for this video. Example 5, that's going to be number 28. Sketch a graph of the function as a transformation of one of the toolkit functions. This is going to be very similar to the previous example, but now they don't give you the graph because you should know these toolkit functions by now. I'm not saying everyone's going to know the toolkit functions, and I will hate you if you don't, but this really should be the time when you are becoming more familiar with those toolkit functions. So we're going to do a very similar thing. In 28, we have h of x is equal to the absolute value of x minus 1 plus 4. And this is the problem when I look at something while I'm writing. Look at this. Check this out. Just wrote this function like perfectly in the middle of the other thing. Okay, let's try this again. H of x is the absolute value of x minus 1 plus 4. Much better. Good job, Jason. So we're just going to draw the original function, the toolkit function, and we're going to draw the function transformations. All right. And again, if you have graph paper, that's recommended, but I'm not forcing people to get graph paper. And so with that in mind, I'm showing you what you can do if you do not have graph paper. So we need to look at the toolkit function, absolute value of x. And again, what if you don't remember toolkit functions? Well, if you don't remember toolkit functions, make sure to have 3.2 open. 3.2 has all of the toolkit functions. Listen right here. So we just have to find the one that we want. Okay. Aha. Absolute value functions right here. So it's just the identity function, but it bounces up and always stays positive, like a v. Right? So the absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3, etc. And the absolute value of negative 1 is a positive 1. When x is negative 2, its absolute value is positive 2, etc. And we really do get that v shape again. So this is the toolkit function right here. And now we need to apply the function transformations to this toolkit function. What transformations do we have right here? We have something on the inside and something on the outside. Outside means vertical. Inside means horizontal. This is going to mean up 4 right here. This is going to mean right 1. Remember, you can consult your table. So we just look at all these points and move them right 1 and up 4. This point, right 1, up 1, 2, 3, 4. This point, right 1, up 1, 2, 3, 4. This point, right 1, 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 1, 2, 3, 4, up, etc. You get the idea. All right, and now we get the same shape. It's just moved around a little bit. All right, this is h of x. Again, the toolkit function is in black, and the modified function is in red. A lot of times it can be a very good idea using 2 different colors and doing these on the same graphs. Okay? One more problem I want to do today in this video. Well, we're doing way more than this, but in the video, only one more problem. All right, so that's going to be example 6. It's going to be number 40. All right, so let's leave 3.2. Go back to 3.5. So number 40 says, here's a graph. Find the equation of it. So if this is a graph and we need to find the equation of this, first off, we need to identify the shape. What shape is this? So it's a shape that starts up, curves, kind of looks like sideways parabola, but only half of it. This is the square root function. And again, if you don't remember, go back to 3.2. Find it on that list of toolkit functions. Okay, so the first thing to identify with this problem is, oh, okay, this is a square root function. Y equals the square root of x is our toolkit. Most important thing here. That's a k, by the way. And then we have to identify, okay, what's happening to this function? Well, normally the square root function starts over here and goes up. This has gotten shifted. Got shift left 2 units and down 2 units, right? It normally starts here, but now it's starting here. It got shifted left 2 and down 2. So we go over here. Okay, it got shifted left 2 units and down 2 units. Write them out like this, because then we can do it one at a time. Keep things manageable for us. And goodness, this video, speaking of one at a time, is way too long. This is the last example. Okay, so left 2. Left, remember, horizontal means on the inside. Is it a +2 or a -2? I don't remember. I'm lying. I do remember. But if I don't remember, what is left? Left is a plus. Okay, plus on the inside. All right. So it's going to be +2 on the inside. That is what happens when we move it left 2. And now we need to do the same thing, but now we have to make it down 2. That's going to be a -2 on the outside. And this right here is going to be our answer for number 40, or example 6. Okay? You should be prepared to do the first chunk of problems, so go ahead, work them out, and then watch the next video.